All right, hello and welcome back, guys. In this video, I'm going to be taking you through the work solutions to the 2024 Exam 1, going through the how to answer these questions, work solutions, as well as sort of a few of the things that the examiners are looking for. We'll also talk about the average number of marks that students actually got right on these questions, which will give you an indication of which questions are easier, which questions are harder, and then you can sort of work out where you fit within that. So if you're not getting the questions that most people get right, then maybe you should really focus on those easier questions. And if you're aiming for a really high study score, then maybe you should be focusing on the questions that not many people get, because then you can try and aim to separate yourself out from those other people. So we'll talk about all of that. But yeah, your general idea going into exam 1 is that you need to be really good at using algebra, you need to be really good at using your formula sheet, and you need to know how to simplify expressions. So using your exponential laws, your log laws, fractions, everything like that, super important. Okay, so here's our formula sheet up on the side here. I'm going to be referring to that one quite a lot as we go forward here. So starting out here, we've got question 1. Now question 1's always, well, usually, I can't guarantee anything, but it's typically for the past few years been a differentiation question. So we're going to take a look at our calculus section of our formula sheet, and just over here we have the formulas that you need to be looking at: the quotient rule, the product rule, the chain rule. They're the ones that we should be looking at. In this first function here, we have a function that is equal to one function times another function. So we can say that e to the x is f and cos 3x is g. And if we know that we're taking the derivative, d dx, of fg, the derivative of that is going to be equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So this is the product rule. It's also written like this. So let's go ahead and do that. So we know that y is equal to ex cos 3x. So therefore dy dx is equal to ex. So the derivative of ex is just ex times cos 3x. We leave that function the same. Plus, this time we're going to just write the function ex, and then we want to multiply that by the derivative of cos 3x. So the derivative of cos 3x, well, the derivative of cos is negative sine, and then chain rule on that again, we get negative 3 sine 3x in there. Okay, so that's our answer, and we just need to tidy it up a little bit. We can also try and simplify it by factorizing it real quick. So we can see here that the common factor is e to the x. So therefore we can write this as e to the x times cos 3x minus 3 times sine 3x. So you can write it in factorized or expanded form. It doesn't really matter. But yeah, basically 0.8 was the average mark for this question here, which essentially means that about 80% of students across the state got this question correct. So this is considered one of the easier questions on the exam. All right, so moving on to the next one here, this is a chain rule question. So we should look at this function. We can see here that we have a function which is contained within another function. So we've got a log, and then we've got a another thing here, which is a polynomial. So we're just going to say that that polynomial is u. So we're going to be deriving with respect to u, and then we're going to be taking the derivative of u with respect to x. So this is basically the rule that dy dx is equal to dy du times du dx. So let's go ahead and do that. So first up, we want to find what is the derivative of x. The question is actually asking for the derivative when x is equal to 3. So we'll first need to find the derivative of x and then substitute that in order to find the value here. So let's go ahead and do that. So we're going to first take the derivative of x, which will come out as, so dy du, we should say, yes, so this is u. Yeah, I've already written that there. So dy du, so that is going to be, what's the derivative of log ex? Well, the derivative of log ex, we've actually got that written right here on the formula sheet. It's 1 over x. So that's going to be 1 over u in this case. And we've got that multiplied by the derivative of u, which is going to be 3 times x squared minus 3. So just knowing how to derive just what is effectively just a normal polynomial. So everyone should be okay with that. Now u, as we remember, is equal to x cubed minus 3x plus 2. So let's write this out in full. This is going to be x cubed minus 3x plus 2 down the bottom in the denominator. That's our derivative right there. But the question, like I said, is actually after the derivative when x is equal to 3. So let's go ahead now and substitute in x equals 3. We have 3 times 3 squared minus 3 over 3 cubed minus 3 times 3 plus 2. So taking that substitution there, we then need to simplify that down. We'll end up with a fraction. So over here we have 27 minus 3 over, again, we've got 27. That's 3 times 3, so minus 9 plus 2. That's equal to, okay, so up the top here we have 24. And down the bottom here we have 27 minus 9 is 18 plus 2 is 20. So this is 24 divided by 20. So like I said, you need to know how to simplify your fractions and these things. So we should see here, both of these divide by 6. So therefore, we can write this as, well, both of them divide by 4, sorry. So 24 and 20 divide by 4. So we have 6 over 5 as our final answer here. And it turns out that the average mark here for this second question was actually 1.2 marks. So once again, most people are getting at least part of this question, but it looks like a lot of people screwed up that substitution step there. So maybe you're okay with using the chain rule. If you're the average person, I guess, you're probably okay with using the chain rule, but maybe you need to work a little bit on your fraction simplification skills potentially to get this one right, or you're fine with that and you will want to move on. All right, so question 2 is where things start getting a little bit challenging, I would say. There's quite a lot to unpack with this question here, so I'm going to take you through the steps for basically how to approach a question like this. So the question says, consider the simultaneous equations, we've got them there, and we want to know what's the value of k for which the system of equations has no real solution. So as soon as you see that no real solution, and we see we've got linear equations over here, remember a linear equation is just a straight line. So if the system has no real solutions, what are the geometric interpretations of that? What it means is the gradients are the same and the y-intercepts are different, right? Because the two lines are parallel to one another. So effectively what this question's asking us is, what are the values of k and what's the value of k such that these two equations come out to have the same gradient and different y-intercepts? To work that out, we're going to need to start by transposing these equations to get them into standard, y equals mx plus c form. Have a look at their gradients and their y-intercepts, and then compare them. So let's just transpose to make y the subject. That's going to be our starting point here. So going off the bat here, equation 1, we're going to write that down here. So that's 3kx minus 2y equals k plus 4. We're going to rearrange that. So first we can just minus this from both sides. We've got negative 2y equals k plus 4 minus 3kx. Okay, and then we're going to divide both sides by negative 2. That's going to come out as putting in y equals mx plus c form, that's 3 over 2k times x, because that's a double negative, of course, negative 3 divided by negative 2. And then over here we have plus k plus 4 over negative 2 as our y-intercepts. Okay, let's now have a look at the second equation. So the second equation is k minus 4x plus ky equals negative k. And let's go ahead and rearrange that guy. We have ky is equal to negative k minus k minus 4x. And then we will divide both sides by k. So this is going to come out as, if I rearrange this slightly, this is going to be negative k minus 4 over k minus k divided by k, which is just 1. So negative 1 over there. All right, so let me just double check that I'm on the right track so far. Yep, so that's looking good so far. Yeah, so we can leave it like that. I won't rearrange it any further. Okay, so let's just move on to the next question. So step 2, once we've transposed these two equations to make y the subject, we're now going to equate the gradients, right? So again, the two equations, if they have the same gradient as one another, they're either the same line, in which case there are infinitely many real solutions, or they're two different lines with two different y-intercepts, in which case they are parallel to one another. So let's equate the gradients. That's the thing in front of the x. I forgot to put the x in here, didn't I? So we've got the two gradients for these two lines. Let me, where is the color for this? Should probably teach myself how to use this. I guess we're stuck with blue. That's all good. So we're going to equate the two gradients. So the gradient of the first one is 3 on 2k. The gradient of the second one is negative k minus 4 over k. So that's this and this for the two equations here, right? So let's look at those. First thing we need to do is get rid of this little fraction over here. So let's multiply both sides by k to tidy things up a little bit. That's 3 over 2k squared is equal to negative k minus 4. All right, what else can we do to neaten this up? Well, what we could do is we could let us just expand this negative here because it's a little bit annoying. So that can be equal to 3 over 2k squared is equal to negative k plus 4. All right, that's good. What about making one side equal to 0 so that we've got a nice little quadratic equation here? So that's going to be equal to plus k minus 4 is equal to 0. Okay, that's looking pretty good. That's looking pretty good. How about we now times both sides by 2 to get rid of that non-monic? Because whenever we've got a fraction in the leading coefficient, it's going to cause some problems. So we can write this now as 3k squared plus 2k minus 8. And of course, if I go 0 times 2, that's still just equal to 0. So that doesn't cause any issues. And now I can just factorize this expression here. So what we have here is, well, we've got a non-monic expression, right? So the first thing that we're looking for are two numbers that add to give 2 and multiply to give 3 times negative 8. So that comes out as negative 24. So we're looking for two numbers that add to give 2, multiply to give negative 24. And those two numbers are going to be 6 and negative 4. So that's going to be 3k squared minus, plus 6k minus 4k minus 8 is equal to 0. So now we can go ahead and fully factorize this. We're going to factorize the two halves of that quadratic expression. We take out, okay, these first two terms here, 3k squared plus 3k. They've got a common factor of 3k. Take that out, we're left with k plus 2. And then over here, these second two terms, minus 4k minus 8. They've got a common factor of minus 4. So we can take that out, we're left with k plus 2. That's equal to 0. That's a common binomial factor. That's really good. So that comes out as k plus 2 times 3k minus 4 is equal to 0. And when is that equal to 0? Well, that's equal to 0 when k equals negative 2 and k equals 4 over 3. Those are our two possible solutions. All right, so let's just take stock here. What we're saying here is that the two equations have the same gradient when k is equal to negative 2 and k is equal to 4 on 3, right? So one of those cases is the case where the two lines are parallel. That's the one that we're looking for. And the other case is the case where the two lines are actually the same line as one another. So let's now go ahead and try and figure out which one's which. So we're going to do that by comparing the y-intercepts. So let's go ahead and substitute them in. And just remember, we have the two y-intercepts up here. The first y-intercept is this bit. So the mx plus c form, remember that's y equals mx plus c. So that's the y-intercept of that first equation. And negative 1 is the y-intercept of the second equation. So we want, what we want is for the y-intercept of the first equation, which is k plus 4 over negative 2, we want that to not equal negative 1, right? Because if it equals -1, that means that this equation here, that first equation, has the same y-intercept and the same gradient as the second equation, which just means that it's the exact same equation. So the two lines have infinitely many solutions. So let's start with, which one should we start with? Let's go with k equals -2 because it's probably a bit easier. So let's go consider k equals -2. So putting that into this equation, we're going to get -2 plus 4 over -2. So -2 plus 4, that is equal to positive 2. So positive 2 over -2, that's actually equal to -1. So that means that they would have the same y-intercepts. So that's no good. That's the solution that we don't want. So that means that when k equals -2, the two equations have infinitely many solutions. So we need to consider k equals 4 on 3 instead. So if I substitute 4 on 3 into this expression, what do I get? I'm going to have to do a bit of fraction simplifying here. So 4 over 3 plus 4 over -2. Well, we've got two fractions up the top, so let's make them have the same denominator. Oh. So 4 over 3 plus 16, sorry, how do we make 4 have the same denominator as 3? It would be 12 over 3. Yep, so 4 is equal to 12 over 3. Divide that by -2. So that's going to be equal to 16 over 3 divided by -2, which is equal to 16 over -6, which is equal to 8 over 3, or -8 over 3. And what's important about that is that that is not equal to -1. So if that's not equal to -1, then that means that we found when k equals 4 on 3, the two lines have the same gradient and they have different y-intercepts. So that is our solution to the problem. So you can see quite a lot to unpack with that question. And like I said, this is where things start getting really quite tricky. So that question there was an average mark of 1.7 marks that people got right, and only 37% were fully correct. So pretty small percentage of people getting that particular question one completely right, but you can still see most people are getting about half of the marks there. So still not quite in the real hard territory, but we're getting there. It's definitely ramping up as we go forward. Okay, so moving on to this next question here, we've got a graphing question. There's usually probably one of these on the tech-free question, on the tech-free exam, maybe two graphing sorts of questions. So this is just asking us to just go ahead and sketch a graph. We've been given a truncus. So let's check to see if we know how to do that. So first thing that we should look for here is maybe the asymptote. So that's probably the easiest thing to look at. Or the asymptotes, I should say. So the first thing is there will be an asymptote when we're dividing by 0, right? So if we have x plus 3 squared equal to 0, then we're going to have a problem because we're going to be dividing by 0. When will that occur? That'll occur when x is equal to -3. So right off of the bat, we can go ahead and label it just down here. Let's try and make it a bit more accurate than that. We've got our asymptote going down the line here at x equals -3. Right? That's our first asymptote. Secondly, we've got a horizontal asymptote. So that's our first vertical asymptote there. The horizontal asymptote occurs due to the fact that if we divide by a number, we're never going to get 0. So 1 over x plus 3 squared is never going to be equal to 0. Because it doesn't matter how large this number down the bottom here. It could be 1 over a billion, and we've still got a number that's not quite equal to 0. So therefore, that's never equal to 0. So we've got something that's never equal to 0 minus 2. That means that y equals minus 2 is going to be our other asymptote. So we've got a horizontal line going across like this. So that is at y equals -2. All right, we've got those two. That's the easy part. Let's now consider the x-intercepts. Or maybe we consider the y-intercept first, because that might be slightly easier. So y-intercepts, or in this case, there'll be one y-intercept. So the y-intercept occurs when x is equal to 0. So let's go ahead and substitute that in here. We're going to get 1 over, well, if this is equal to 0, it's just 0 plus 3, so 3 squared minus 2. And 3 squared is, of course, equal to 9. So that's 1 over 9 minus, now 2, we could also write that as 18 over 2, so 18 over 9. So therefore, we've got 1 over 9 minus 18 over 9, that's equal to minus 17 over 9, which is a little bit larger than minus 2. So that's going to be somewhere about here. So that is our y-intercept, 0 minus 17 over 9. Beautiful. Okay, what do we do with that? So now we need to figure out our x-intercepts. Our x-intercepts, right? The x-intercepts occur when when y rather is equal to 0. So we have 1 over x plus 3 squares minus 2. When is that equal to 0? So to solve that, we need to add 2 to both sides. So we get 2 equals 1 over x plus 3 squares. Then we're going to multiply both sides by that x plus 3. So, sorry, x plus 3 squared. So that's going to come out as 2x plus 3 squared equals 1. And then we're going to have to expand those brackets a little bit over here. Sorry, yeah, we don't have to expand the brackets. We can just divide both sides by 2 here. So we get x plus 3 squared is equal to a half. And then we can square root both sides. That's better. X plus 3 is equal to, well, the square root of 1 is just 1, so it's 1 over the square root of 2. And don't forget, there's a plus or minus there, so we've got a positive and a negative root. Running out of space. Let me just bring it over here real quick. Okay, so we have that x plus 3 is equal to, okay, so 1 on root 2, that's the same as root 2 on 2. So always remember to rationalize the denominator with these sorts of questions. And then we're going to minus 3 to both sides. So that's going to come out as minus 3 plus or minus the square root of 2 over 2. Those are our answers here. So let's go ahead and put this in here. This first one here is slightly larger than -3, so that's -3 plus root 2 on 2, 0. And the other one is going to be over here at -3 minus root 2 on 2, 0. Just like that, okay? So those are our two x-intercepts, and all it remains is just to fill in the general shape. So we know that as we get closer to that asymptote, it's never going to quite reach that value of x equals -3, but it's going to get really close. Going to go up like that, get really close to that point, getting closer and closer to that point. Okay, and then meanwhile, it's going to get closer and closer to this point over here. It's never going to quite reach it. It's also going to pass through this point here at -2, -1. And also this point over here at -4, -1. And, it's always good to use this grid as much as you can. You should be able to look at this function up here and see that, okay, well, when x is equal to -2, we're going to get -2 plus 3 down the bottom. So that's 1. And 1 over 1 squared is just equal to 1. So that's going to be equal to -1. So just look for those little details. It just adds to the accuracy of your graph. I don't think it was really necessary here to use that, but the thing is, like, it depends on how well students do on this type of question. So if everyone's getting really good graphs, then VCAA is going to be extra harsh to separate out the higher students from the lower students. In this case, the average mark last year was 2.1 marks. With only 42% of people getting full marks. So most people are getting something here, but not a lot of people are getting full marks. So like I said, just be as particular and accurate in your work here. Just make sure you've rationalized the denominator, make sure that you've included all of these coordinates, the asymptotes, label your asymptotes, and then, yeah, look for those extra levels of detail in the work there. All right, so moving forward, what do we have to do next? So next question is asking us to determine the region of the region that's bounded by the line x equals -2. So that's this line here, x equals -2. The x-axis and the y-axis. So that's this little shape right here. So we're trying to figure out what is the area of that shape there. So whenever you've been given an area question, you just need to remember that the area is equal to the absolute value of the integral. So this is the absolute value of the integral from -2 to 0 of the function g of x, right? And as we can see, don't forget the dx at the end there. As we can see here, this is negative, right? So the function is negative below this point. So because this is a negative integral, we need to account for that by actually taking the negative of this integral. So it's the area below the curve, so we need to include a negative sign out the front here. So this is negative of -2 to 0 of the function gx, which we can chuck in is 1 over x plus 3 squared minus 2 dx. Okay, that's our function. So let's go ahead and try and simplify this. So the first thing that might make your life easier and personally will help you avoid making mistakes with negative signs is if you have a negative of an integral, you can just take that in by swapping the two terminals. So that can be written as the integral from 0 to -2. See how I've just swapped the -2 and the 0? That accounts for the negative sign. So that just might make your life a little bit easier. It's a nice little trick. Also, write this fraction here using negative powers. So that's x plus 3 to the power of -2 minus 2 dx. So that's going to come out as being equal to the integral from 0 to -2 of, okay, so first up, we're taking the derivative of this. So that means that we are going to bring that power out the front. So we're going to multiply through by -2. And then we're going to, sorry, no, we're taking the integral. Yeah, we're taking the integral, not the derivative. So, okay, taking the integral, we're going to increase the power by 1. So that's going to go up to x plus 3 to the power of -1. And then we're going to multiply it by the new power, which is power of -1. So this is going to be a negative sign out the front here. Yeah. Minus 2x dx. That's the integral that we are evaluating over here. So let us go ahead and substitute that in. We have that this is equal to, so I should have written this without that. So that's with the square brackets, we've taken the integral, so that is -2 to 0. We use these square brackets at the end. We've gotten rid of the dx and everything over here. Okay, so now we'll go ahead and substitute those values into this this indefinite integral to find the definite integral. So let's go ahead and do that. We have negative of 0 plus 3 to the power of -1 minus 2 times 0 minus so it's double negative here. So minus negative x plus 3 to the -1 minus 2. Sorry, the x there, forgot to do the substitution. That is -2. So -2 plus 3 to the power of -1 minus 2 times -2. Okay, so let's see if I can get this right. Okay, so first up, this is -1/3. Then we've gotten rid of that 0, so that's -1/3. Where did I go wrong here? So it's from 0 to -2. So I should have put these in the other way around. Yep, okay, so that should have come out as, should have put in the -2 first. Damn it, that's annoying. Oh well. Can I erase that? Should be able to. So this should have been... No, okay. That's frustrating. Let's just go back to this. Okay, let's just do this. So okay, this is -2. That here is -2. This here is 0. That's 0. Right? I've just put them in the wrong way around. Okay, so let's do that. So this comes out as negative of -2 plus 3. So that is just 1 to the power of -1, which is just 1, minus 2 times -2. So that is plus 4. And then we have minus negative a half. So that is negative a third, not negative a half, minus 2. Okay, beautiful. So that comes out as 4 minus 1, which is 3. And we've got plus a half, so that's 3 and a third, which is the same as 10 over 3. And that's the final answer there. So for that particular question, that's an average of 0.8 marks there. And I really think that the difficulty here comes from the negative signs and just being really careful with that substitution at the end there, just not to screw up your simplification. All right, moving on to the next question. Okay, so this is where your formula sheet is going to be really handy, right? So whenever we're dealing with these probability questions, we've got standard deviation, we've got all of these different things. Just look at your formula sheet would be my advice for this. So right off the bat, we've got let x be a binomial random variable. I'm going to go straight to my probability distribution section of the formula sheet. We're going to look at, okay, there's binomial, right? There's our formulas. Right, variance square root of that is equal to standard deviation. So that's what we're looking at. We're looking at this formula right here. So before we go any further, that's the formula that we need to look at for the standard deviation here. Now, the way that this is written is that we're told that x is a binomial variable such that n is equal to 4. So that's our n there, and the probability is equal to 9 over 10. So that's, we've written this as x is a binomial variable with that's its number of trials and that's its probability of success. So let us go ahead and work out the standard deviation. So we're going to use this formula from the formula sheet. Make sure that you use the right formula. But yeah, if you can correctly identify it's a binomial random variable, you should get this formula right here. And then all you have to do is just substitute in the numbers into it. So we've got 4 times the probability of success, which is 9 over 10, times the probability of failure, which is 1 over 10. So if there's a 90% chance of success, that means that there's a 10% chance of failure. Okay, so now we can simplify that down. We have here, okay, we can see that that's the same as the square root of 4 times 9 over 100. That's going to be equal to, taking the square root of all of those, that's 2 times 3 over 10. I've just gone square root of 4 is equal to 2, square root of 9 is equal to 3, square root of 100 is equal to 10. And then that comes out as 6 over 10, which we can simplify down to 3 over 5. That's our final answer for this particular question. Was done pretty well. This was an average mark of 0.6 was the average here, so 60%, pretty good, I would say. You should be getting that question right. Okay, next question here. We've got the probability that x is less than 2. Now, once again, with these sorts of questions, think about the context. So we're dealing with a binomial random variable. So if we're dealing with binomial variables, we're looking at this sort of thing. So this is the binomial distribution. You should be thinking combinatorics for this sort of question. So we can see here that the probability that capital X is less than 2 is going to be equal to the probability that X is equal to 0 plus the probability that X is equal to 1. Okay, so let's go ahead and substitute those in, or just consider each of those two cases. All right, so how could x be equal to 0? So what we've done here is we've done 4 trials. So we've tossed 4 coins into the air. The probability that one of them lands on heads is 90%. What's the probability that all of them failed? Well, for all of them to fail, that means that the probability of one of them failing is 1 over 10. And all 4 of them failed, so the probability of them all failing is 1 over 10 to the power of 4. Okay. Now, what about the probability that exactly one of them succeeds? Well, that's going to be 9 over 10 to the power of 1 times 1 over 10 to the power of 3. So, in other words, one of them succeeded, 3 of them failed, and there are actually 4 possible choices for which coin could have succeeded. Right, so for which trial could have succeeded, there are 4 possible choices. That's where this part of the formula comes in. That's the 4 choose 1 components. Okay, so let's go ahead and simplify that down. This is 1 over 10 to the power of 4 plus 36. So 4 times 9 is equal to 36 over, this is 10 times 10 to the power of 3. So that comes out as 10 to the power of 4. And collecting that together, we have 36 over 1 followed by 4 zeros is our answer here. Sorry, not 36, because that is 1 plus 36. So 1 plus 36 is equal to 37. So that should be 37 over 10 thousands is our final answer there. And for this particular question, there was an average mark of 1 mark. So a lot of people getting this partially right, but not a lot of people getting it fully right. So once again, may have been that they showed a little bit of the right method, but they didn't quite get that final answer of 37 over 10 thousands. All right, so this might be a good place for us to take a break. I'll be back with part 2 in another video. I'll talk to you guys soon. Have a good one.